So, today we will take some specific points on the some important points on the polymers. The meaning of poly means many, mers means molecule. So, therefore, here the as per the definition polymers means smaller molecules, relatively smaller molecules when joined and gives a large size molecule is called a polymer, and the process is called polymerization. Like for example, if you take a very small molecule ethylene and a number of ethylene molecules may join to give a long chain compound containing only CH2, 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 very long chain will be sometimes thousands to millions molecules will be there, which may be represented with a repetitive unit as a CH2CH will be n times. So, if this compound is called ethylene, the starting material which is called a monomer here, ethylene, this we call monomer. The one which gives the polymer is called monomer, and this on polymerization giving, so therefore its name will be poly and ethylene, polyethylene. May be having a also called as polythene. So, this is a polymer, and which starts that polymer giving this molecule is called monomer. So, in a polymer always we have to remember where from it is formed. So, that monomer is also one of the important point. So, the polymers will have a gigantic structure, and this structure helps for the stability of the compounds, and they have some unusual properties, like these are all specifically organic compounds, and in organic polymers like silicones, silicates are there. Now, in this class we are restricting only for the organic polymers, and these polymers if you see considerably, they are nothing but the organic compounds, but we are carrying some organic solvents in the polythene covers, means this polythene substance is not soluble in the so called organic powerful solvents also. That shows the gigantic structure of this compound will show some unusual properties, like very much extraordinary stability and less solubility in the organic solvents and less reactivity. So, therefore, the long standing capacity, and these are the even in the nature also, if you find the polyamides that are used for the construction of our body, and the cellulose is the construction for the plant material, and so on. Most of the polymers are used for the construction of the human body and the construction of the plant body. That shows the polymers are very stable, and in the nature the preparation and the operation of these polymers will be oftenly we find. However, now we go to the one of the aspect is the classification of the polymers. The classification, there are 4 different varieties of classification is there. The first classification is based on the source, based on availability or the source. They can be divided into the 2 types, natural and the synthetic. Natural and the synthetic. Some of the natural examples are silk, wool, and the cellulose, starch, natural rubber, and these are all the natural examples we have. In synthetic, as I said, polythene, nylon, and terylene, bakelite, and so on. Man-made polymers, huge number of polymers we are using in the industrial and economically wherever it is necessary. So, this is one way of classification. We too can have a via media type. Sometimes, for example, if a cellulose is a natural one, but the cellulose nitrate is used in the preparation of gun cotton, and the cellulose acetates and all that used in the polymers as rayons and all that. These are partially natural, partially synthetic. Like in the rubber also, what we extract from the plant is totally natural, but sulfur addition we are developing some cross-linked that comes under the partially the natural, partially synthetic via media type of third variety also can be observed. That is natural only, but slight modification gives the third variety of the polymers. Similarly, based on the how they are formation, based on formation also we can classify. The formation can be classified into the two types: adhesion polymers and the condensation polymers. In the adhesion, the double bond, if it is added to the another double bond, so this double bond comes here, this double bond comes here, and so on, a polymer is formed, like a polythene formation is an example for the adhesion polymers. In the condensation, a compound will have a OH, let us say, another compound also there is a OH. So from these two OHs, one water molecule is dropped, and the two molecules are joined with the ether bond, ester bond, amide bond, and so on. Water is dropped and the two molecules are joined. Similarly, other side, if it is having a one more function, it will join with the next molecule, and so on. Condensation leads to give the very big large molecule. Through this, while forming the one water molecule or the ammonia or the alcohol, such smaller molecules are removed. Such polymerization we are calling as a condensation polymers. These are the two types. The third variety of the classification is based on structure of the polymer. Some polymers may be linear, that is a line shape will be there, so they are called linear. The others are called the cross-linked or (3D) type or cross-linked. Linear and the cross-linked. So a molecule will be a straight line type, having maybe sometimes here and there branches, but the cross-linked means two polymers are attached through the in-between lines like this. So sometimes sulfur addition is an example for the cross-linked formation, but this cross-linked formation will have a net type of the polymers. Linears will be the suitable for the industry where textile industry and so on. This is the based on the structure we can define into the two types. The fourth variety is based on the property. They are divided again into the basically two types. That is thermoplastic and the thermosetting. Thermoplastic means once a solid polymer is formed, this solid when you heat it, it will give liquid. The liquid, when you cool it, again you will get the back, this is solid. This is called what? A recyclization of the polymer. So once we prepare an article with the polymer, that article, if by chance if it breaks, we can go for the heating and get a liquid. Once again the same article or some other article may be remolded. So type of the recyclization, generally it also depends partly on the structure. Mostly the linear polymers will have this type of the thermoplastic property, whereas thermostatic property means when once the polymer is formed, it will not if you heat it, it burns, but not the liquid formation will not take place because of the cross-linked formation. Sometimes the whole molecule will be in single molecule. So in such a case, the melting into the liquid is highly impossible. But if you heat it strongly, what happens means it may take up into the char formation, that is black carbon powder formation, or it may catch fire, but it won't melt into the liquid. So in such a case, recyclization will not be possible. An example, bakelite is an example of such a variety. Bakelite is prepared out of the formaldehyde and phenol formaldehyde polymers, which will give a three-dimensional type of the polymers, and generally such a type of polymers cannot be recycled. They are called thermosetting polymer. However, they too have the thermosetting properties also will be used in the preparation of a handles of a pressure cookers and the ironing, and wherever the heat attachment is there, such a type of the articles can be beautifully prepared out of this bakelite type or the thermosetting polymers. We too can have two more classes like elastomers, where some polymers will have a elastic property, and also fibers formation, also two more classes will take, but basically they are divided into two types based on this recyclization property. These are the four different varieties of the classification is based on the slide based on the source, formation and the structure and the property.